We have two more application problems we need to take a look at. To start with, we have the small theater problem, where we have a seating capacity of 2,000. And when the ticket price is $20, the attendance is 1,500. So that means the attendance is the Y value because the ticket price determines the attendance. So the attendance is Y and the price is X. And we're supposed to find a linear function, which everything we've done on applications thus far have been quadratic. And a linear function, if you remember, is y equals mx plus b. In this section, it was given as f of x equals ax plus b. But the mx plus b is something from a previous class, so you're okay to think of it that way. The ticket price is $20, and the attendance is 1,500, and that's a point on our graph. So f of x is equal to 1,500. Once again, price is x, attendance is the y value. Okay, so now, for each $1 decrease in price, attendance is increased by 100. That's a slope right there. The attendance, the y value is 100 for the slope, and the ticket price, the x value, is -1, and it goes in the denominator, y over x. So the slope for our linear function is a -100. So we are to find a linear function. Here we go. Y equals -100, our slope, times x plus b. We don't know what the y-intercept is, but we have this point, f20 equals 1,500. So plug it in, and let's find our b value. So the b value is 1,500 is equal to a -100 times 20 plus b. Solving that, we get 1,500 is equal to a -2,000 plus b. Add 2,000 to both sides, and we get b is equal to 3,500. Right, put that all together. So our linear function f of x is equal to a -100x plus 3,500. And that, once again, represents attendance. On part B, we're asked to write a revenue function based off of ticket price. Well, revenue is how much money you bring in. And in this particular problem, the amount of money that you'll bring in is the number of people that attend, so your attendance, times how much they had to pay to get in. So how much they had to pay for the ticket price. So their cost of ticket. So the revenue function is going to be a product function, and we already have the attendance written out above. So for the attendance, all I have to do is put into my revenue function -100x plus 3,500. So that represents the attendance part of revenue. And then the cost of the ticket is just x. And that's a revenue function. That's how much money these people are bringing in. Now, we have to, there's a difference between revenue and profit, but how much money they have on the front end is given by this function. And then the ticket price, we want to find the ticket price that will yield the maximum revenue. This is a parabola. It opens downward, so it makes sense. The vertex is going to be the maximum. So r of x is equal to a -100x squared plus 3,500x. Put that on our calculator. You hit graph. You're going to have to play with the window some. So let's go over here and look at these numbers. Let's go to our window. And let's start off. Once again, this is kind of glitchy. The buttons are, so it's moving around a little strangely. I apologize. We're going to start off by changing our X max. Let's say we have 50 people, $50 as the price of the ticket, and we have a maximum. We're going to set our Y window maximum to 10,000 people attended. Okay, yeah, our maximum is still off the screen, so we need to go back to our window, and we need to change our Y max. Let's say 50,000 people attended. There we are. We have a nice view of that maximum. So now go into second, calculate, choose option 4, go to the left of the maximum, hit enter, go to the right of the maximum, hit enter, and take a guess where the maximum is. When the ticket cost $17.50, we have a maximum attendance of 30,600. Sorry, we have a maximum revenue of $30,625 because this was the revenue function. All right, so the ticket price is $17.50 to give us our maximum revenue. Let me get this written down in this blank. So the revenue is equal to $30,625.